Today's aim is that students will be able to solve an equation by splitting it into two expressions and graphing. Let's look at some vocabulary first. An equation is made up of two expressions that are equal to each other. To solve an equation means to determine what value for x or any other variable will make the equation true. If the equation is never true, we say it has no solution. If the equation is always true, we say it has infinitely many solutions. Today we're going to learn a new way to solve an equation by graphing. Here are the steps. Step 1. Split the equation into two expressions, left side and right side. Write each expression as a new equation in the form y equals mx plus b. That's slope-intercept form. Then graph each new equation. Identify the y-intercept and plot it on the graph first. Then identify the slope, the m, and use rise over run to plot two more points from the b. Number 4, identify the point of intersection where the two lines cross. The solution is the x value at the point of intersection. If the lines are parallel and never cross, there's no solution. If the lines are the same, that means they're right on top of each other, there are infinitely many solutions. So let's look at an example. The directions say, solve the following equation by graphing. Check your answer by solving it algebraically. So what I'm going to do here is first split my equation just like I normally do down the equal sign. Except instead of solving this algebraically, I'm going to solve by graphing. I'm going to make each side of my equation a different equation. So I'm going to have y equals, and then I'm going to use just the left side, 2x plus 3. And then I'm going to write a second equation, y equals, the right side, x minus 2. Now I know in order to graph these equations, I need to know the slope, the m, and the y-intercept, the b. This is a review from what we did a few weeks ago. So in this one, I see my slope is 2, or I know that that's the same as 2 over 1. There's an invisible 1, and I want my slope to be in the form of a fraction. And my b, my y-intercept, or my starting point, is 3. In this equation, I know there's an invisible 1 here, so my m is going to be 1, or 1 over 1. And my b is going to be negative 2. Now what I want to do is graph each of these lines and see where they intersect. Where do they cross? So I'll start with the first one. I always start with my starting point, my y-intercept. That's what I graph first. So I'll just do this first equation. b equals 3. So on my y-axis, I go to b or to y equals 3. And there's my first point. Now I use my slope to plot more points. So I know that this is a positive 2, so I'm going to go up 2, and this is a positive 1, so I'm going to go to the right 1. So I'm going to go up 2, 1, 2, over to the right 1, up 2 to the right 1, and I could keep on doing this, up 2 to the right 1, or I could go backwards. I could go the opposite directions, down 2 to the left 1. See, I'm always going to stay on my straight line. When you're graphing to solve, it's very important that we plot a lot of points. We want to cover our whole graph with lots and lots of points. So I'm going down 2 to the left 1, and so I get my nice straight line. And I'm not going to draw my line just yet. I'm going to graph my second one. I'm going to label this A. Okay, so this is line A right here. I'm going to now graph line B. Again, I'm going to start at my starting point, my negative 2 on my y-axis, my y-intercept of negative 2. I'm going to graph that first. Then I'm going to go, I know this is going to be up 1 to the right 1. So up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. Or I could go backwards, down 1 to the left 1, down 1 to the left 1. Remember, I'm trying to find where they cross, so I'm getting pretty close here. Down 1 to the left 1, down 1 to the left 1, down 1 to the, ooh, I found the point where they cross. Down 1 to the left 1, down 1 to the left 1. Now I'm ready to draw in my lines, very carefully connecting all of these points. And I remember I put my arrows on both ends. And now I'm going to draw my other line, carefully connecting all of these points. It's really better if you have a ruler. I don't have one of those with me right now. Now what I'm looking for is this point right here where they cross. And what I want to know is what's the x value where they cross? Well, if I go on the x-axis here, the x value is a little hard to see, but it's -5. So the answer, the solution is x equals -5. Make sure I get my negative in there. X equals -5. Because that's where the two parts of my equation are equal. Now I can check my answer by solving it algebraically. So I can go back over here. I know that there's an invisible 1 right here. Well, there's nothing to simplify on each side of my equation, so I'm going to go ahead and combine my variables together. I move the one with the smaller coefficient, the smaller number in front, so I'm going to subtract 1x from both sides. These will cancel out. 2x minus 1x is 1x, or just x, because the 1 is invisible. Plus 3 equals -2. Then I subtract 3 on both sides. -2 minus 3, or -2 plus a -3, is going to give me -5. X equals -5. Well, that's exactly what I found when I graphed it. Now it's time for you to practice.